Oh, 20 Jun kah? Oh, lambat lagi. Oke, boleh nampak my slide?
Boleh, Prof.
Okay, so if you recall back, we have studied decision tree, instant base, naive Bayes, neural network. So all these are different supervised algorithm, but each one of them will have their own characteristic, which means that they will perform better for one data set, but not the other data set. So to complement this error, we can leverage ensemble classifier to increase the accuracy of your classification. So what happened in the ensemble classifier, we combine several machine learning method, and then we can take the majority or take the average based on the voting, so that at least we use more than one classifier to determine the class of the unseen data. Okay. So this ensemble is a very popular now. Now people looking at not a single classifier, but they're looking at several classifier. So they call it ensemble. So ensembling is a technique of combining two or more algorithms of similar or dissimilar type case base. So for example, we can use naive Bayes or naive Bayes for all the classifier, or we can use different model that we have. So for example, this is your original training data. So you create multiple data set. Okay, so they will have different partition of data, and each partition will be used to training different classifier. Either they have the same classifier or different classifier. Okay, and the output of each one of these will be taken, and we will have what we call it the meta classifier, where the input will be converted into a single decision here. So they will take a consensus result, taking the majority voting from all your classifier here. Okay? But the way you arrange your classifier will also affect, or will also be called by different name. Okay, for example, like this is for the taking the average of prediction from model in case of regression. So for regression also, we can use different regression method, and then we can take the average, like this is model 1, model 2, model 3, so the average is this one. Because for the regression, we are looking at what is the forecasted value for the next value. Okay, but for the classification, we are looking at the majority. So the one, the majority label will be used to assign to the new unseen data. Okay, we could also use the weighted average, in which setiap model too, they will have different voltage. Okay, so if this is the predicted value for the forecasted value, then the times the weightage is used to give to indicate that model number 1 has higher priority compared to model number 2 and 3, and this is the weight average prediction. Okay, so we have different name for the ensemble. For example, this one, this is bagging. So bagging consists of several base model on different bootstrap. So This one, different bootstrap means that we partition our data into different partition. So each data set will have different rows. So we feed into the weak classifier, and then we will summarize the output here. Okay. Okay. For the next one is boosting. So boosting, okay, this one you put in parallel. Okay. But for the boosting, you put in sequence. So for example, you have one data set here, then you feed into the classifier here. So you will reuse again the data set here, but again, what happened here is that you focus on, uh, no, you give higher priority to those misclassified. So which means that in each of the model, you will be treating differently for each of the row. So you give higher priority for those who are misclassified. Okay, so we will look into this boosting later on. Okay, we also have this stacking, in which for the stacking, so we will use the same data set here, but for your model here, you will be using, you, you can use different type of model, and then we take the majority voting here. Okay, so the difference between boosting, stacking, bagging. Okay, boosting is in sequence, bagging and stacking they are in parallel, but for bagging they will get different data set. Stacking you will get same data set, and for the stacking you can use different model for your ensemble here. Okay. Okay, so this is the um, summary. Okay, so the bagging build multiple model from different subsample, from different subset of your training dataset. Boosting, you have multiple model, but you learn to fix the prediction error of a prior model in the chain. So basically, you arrange them in a sequence, and then for each of the model, they will try to give more priority on those sample which are misclassified from the previous model. Okay, stacking, um, basically you feed the whole dataset and you can use different model for you to assemble your model. Okay, so we focus on this because most classic one, boosting the classifier. For this classifier, fine, um, we combine several model in sequence. So you will be using the same machine learning algorithm. So the focus is to focus on the misclassified training document. So for each of the iteration, what you need to do, each document is in the training set is given a weight. So weightage. So weightage tell if you have high, you will have higher priority. Okay. So only those incorrectly classified document will be more uh, weight. So and now a few model out of a thread classifier are combined. So you will combine the output in a weight sum. So you have this model. Let me do again. So you have this model. Each of model they will have weight. So you just pass all the model and you look at signage only. I will show you later. So this is the formula is the other. So over here we will have the
Sorry, Prof. Sorry,
yes.
Prof. Suara Prof terputus-putus sebab mungkin internet WiFi kali.
Yeah. Saya simpan layarnya sudah di luar. Boleh sudah? Terang nggak?
Oke, macam oke sudah.
Okay. So for the pseudocode for the ADA boost, we will have the training set function. So we have the data set and also the class label. We also have the size of your training, the number of document that the number of item that we have, and this is the number of time you want to go through your model. So if you have 3 model, that means you have your M value is 3. So it could be 5 or 2, but M here refer to the number of model you want to put in sequence. Okay, so in this case, M equal to 3. Okay, so for each of the item that we have, we need to initialize the weight by giving them this weight lah, 1 over the number of item that we have. So if we have 10 item in your data set, so each item will have 1.0, 0.1 weight, which is 1 over 10 lah. Okay. So for each of the iteration for the model, okay, we learn the classifier function. That means we draw a line to separate the positive and negative. So from there we can know how many error that we have. So this is just to the accumulation of misclassified item that we have. So this is the number of error, and then we can compute the classifier weight by using this formula 0.5 times log. We can use natural log 1 minus the number of error that we have divided by the error. I will show you later on how this one works. And then based on the error also, we want to fix the weight of the classified example by reducing the weight and increasing the weight for the one that is incorrectly classified. Okay, so before we go to the next model, we have to normalize the weight that they sum up to 1. Okay, so this is the example. Okay, we have 10 items here, so the weight will be given 1 over 10. Okay, so that is the weight. Okay, so let's suppose we have the model number 1 classify them as this. So they say that everything on your left hand side is positive, everything on your right hand side is negative. So how many error we have? 3, right? Because the function learn that based on this line, on everything on your left is positive, but we have positive here, so we have 3 error. Okay, so the number of the error is 0.3. Okay, so the model weight can be computed by using this also. So the formula is 0.5 times natural log of 1 minus the error divided by the error, we get 0.42. So that means the weightage of model 1 is 0.4. Okay. Okay, from here we want to make a focus on this 3 and by increasing the weightage. So how do we increase? So basically, we will multiply this number 0.1 with 0.66. How do we get 0.66? Because we get the weightage for the model here. We take the exponential value but minus lah here. Then we get this times the value. So that's how we get this value. This is for the correct one. Okay, so this is for the incorrect one. So for all of the correct one, we will multiply this lah. For the incorrect one, we multiply with 1.52. So we only have 3 incorrect. So we increase the weightage for these 3 guys. Okay? Are you following me? Boleh?
Boleh,
Okay,
Prof.
so now before we move to round number 2, we need to normalize this value. So we add up all these values. And then we take 0.52 divided by the total number of all of this value, so that when we add up all the weightage is 1. Because initially for this we have, if we total up all the weightage, we get 1, right? But this one we already multiply with this. So in order to be on the right track, we need to normalize this one. So that's why in the next one we get this one is 0.152 become 1.65 because we normalize using this value. This is the total of all weight of this. So we normalize lah. Okay, so this is the end of round 1. Okay, round 2. Okay, let's suppose the second classifier make learn the function to be like this. So everything on your left will be positive, right negative. So we have 3 misclassification, right? So we add up this, we get 0.21. We take the model 2 weightage, which is 0.65. Then we compute the adjusted weight. So for all the incorrect one, we will multiply with 1.92. So 1.92 we times with this. 1.92. Okay, so we only times this to the misclassified item. Then we get this value lah. For 0.52, we times with the remaining item which are correctly classified. And this is our new weightage. But don't forget to normalize them. So this is the normalized weightage. Okay. So what you need to know about the first round is, what is the model weight? Okay, this is the model weightage. So M1 we have 0.42. M2 I have 0.65. Okay, so if you move on to the next one, so next one, round number 3. Round number 3, okay, they say that everything on your right, no, on your top of this line will be positive, down will be negative. So we have 3 misclassified, 1, 2, and 3. We add up that value, we get 0.14. Okay, and then we get the weightage for the model. And let's assume we stop here. So there is no more calculation because we don't need to normalize the weightage. because we get the model weight number 3, which is 0.92. Okay. So since our m in this example is only 3, so we can say that the weightage for model, okay, this is model 1, model 2, model 3. So if we combine this, we will become this. Okay. So how to do the prediction? Okay, let's suppose for the x here, we put x1, this is negative, positive, negative. So negative, positive, and negative. So we just multiply. Since the signage is negative, we declare x to be negative. Okay, for the y is here negative, 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 positive, positive. So negative, positive, positive. So we solve this one, we get positive signage. So we say the y is positive. So you can see that the weightage here will tell you it goes positive or negative. Okay, so as you go from model number 1, number 2, number 3, the weightage is increasing. So that means the last one will have higher influence on your final classification. So that is boosting. Okay. Okay. So how do we apply ensemble? So let's do some demo here. Okay. Let me remove this. So we have so many type in. So we install the caret ensemble refer to classification and regression. We also have mm, the the R-lang. So the R-lang is programming languages, and also we have what we call it car tool. This is for the categorical value. Okay, so we also have the regression. Okay, so we just install them. Okay, we will be using the diabetes dataset. So we have this dataset. So we have the type of diabetes is yes or no. We have age and some of the reading. So we have 1, 2, 3, 4, 5, 6, 7. Okay, and then we use set seed because this is just to have the same random number if you want to repeat the experiment. And then this one is to split your data into 75% training and 25% testing. So if we look at the split, this is all the data that we have lah. The raw ID, 75%. Okay, and then we take this one into the training, and then the other one we put in the testing. Okay, okay. So for this one, can you see the slide? The modeling, evaluation, and selection.
Yes, Prof. We can see the slide. Yeah.
Okay, over here we set the control for the classifier. So we are saying that okay, we will use cross validation. Cross validation means we divide them into a few partition, and we use 5 partition here. So that means we have we can say 4 for training and 1 for testing. And then we say self prediction. Here is an indicator of how much of the whole out prediction of each resample should be saved. Okay, so that means we save the final one only. Okay, the class probability logical. So this is true. Should class probability be computed for classification model? Yes, we put true here. The index is a list with element for each resampling iteration. So each sample will have index, and then sampling a single character value describing the type of additional sampling that is conducted after resampling. Okay, resampling up, and this one they have some kind of setting lah, but need to look into do more details. Okay, for this one we will have 2 class summary. So this is the setting that we will be using. Okay, so we will apply this setting in our model. So in our model here, I'm using the control that we have set before. And this is the receiver operator characteristic in which the metrics we use to evaluate the performance of the model. So I will use this one. So this is we model the type of the diabetes based on the remaining data that we have in the trained data set. Okay, what I will be using, I will be using individual uh, machine learning here. Okay, so this is a list. So I've trained them. Then if I look at the correlation between this, so we are looking at how the output looks like for the machine learning 1, machine learning 2, and KNN here. Okay, so we don't look at this, we don't look at this because they are comparing to each other. So we can say that the KNN and Earth is highly correlated. So when they are highly correlated, it's best not to include them together. Okay, so the R part, uh, in this case, this is R part and KNN. In this case, it's Earth and KNN. Okay, so the output is different because we're doing the sampling. Okay, so let's progress by creating the 4th classifier. This is individual classifier. Okay, So let's create by the fourth classifier. So the fourth classifier is basically we are combining all of them. So the model that we have is coming from here, predict. Okay, and over here we are looking at the output of each of the individual will be take as input to the fourth classifier. Okay, this is the prediction, and this is the output that we have. So this is the output for the three um, classifier that we have, and then we should have the fourth one. So what happened in here that we align the ensemble as like this. So classifier 1, 2, and 3. So the classifier 4 is basically taking the input from all these three. Okay. And then we arrange them in the stack. And if we look at the summary, okay, so for this one, we have three. So this is the first three that we have. We're looking at the topology like this. So this is the first three. And then we take all of them and put them in this um, stacking. And the fourth one will take the input from here and then try to take the average and see what is the performance. So the ROC here, the higher the value is, the better. So they are almost the same as the Earth. This one, okay. And over here, we see that the model importance here, the Earth is the most important one because they are closer to the ensemble. Okay. So basically, we are for the stack here. We take all the models here, and then we use the ROC. The this is the control that use bootstrap. Number of bootstrap we have similar to what we have in the control. Okay, so this is just to illustrate to you how do you stack your model that we have. Okay, so if you want to do comparison of individual result, oop, error. The summary is still the same already. Okay, this one, what is the error here? Maybe I'm missing few steps here. Okay, get back to you later on. For this one, we looking because the ROC is depend on the area under the curve. So the more coverage you have, the better is your model is. So we compare this with the tree and also the ensemble. So in this example, the ensemble have more area under the curve, meaning that they are a better classifier. Of course, the accuracy here telling that eh, here, not that one. This ROC here. So although the value is almost the same here, but if you look at here, we need to look at area under the curve because that one I measure um, the the overall performance of your data set. The overall performance of your uh, classifier for the data set that we have. Okay. Okay, but what's wrong with this one in the predict training? I will get back to you to make a correction for this one and how do we analyze. Okay, so that's the whole idea. Any question?
Prof,
So yes.
ya, actually kan Prof, saya buat juga eksperimen on Ensemble
Mm.
for stacking. Setakat ini stacking saja. Kalau stacking ini kan sometimes dia punya performance dia tidak apa kan lebih hebat daripada yang individual.
Yes, sebab taking the leverage the other one because for you to verify this you need to test with few data set. Tidak boleh satu saja.
Oh,
So if you use satu data set saja, so that means mungkin dia lebih prone, lebih accurate untuk satu classifier itu saja. Tapi kalau let's suppose you test untuk five data set, mungkin di sana baru boleh verify the ensemble is better lah.
oke. So meaning kalau kita buat research untuk cek ensemble ataupun kita propose new ensemble, so we
Yes,
need to use more than one dataset lah ataupun
yes,
five lah.
yeah. So because different data set, different characteristic too. So
Oh,
yeah, so that's how you validate lah the ensemble is better lah. So tapi based on previously published work, memang ensemble ini better lah because dia leverage the uh, strong and weak classifier.
mm, mm, mm. Because
And
yang
also,
mm,
uh, but you're doing stacking kan? So
ya,
stacking that means you are feeding with the same input kan?
mm. Because yang current punya yang saya buat nih macam small research juga lah about yang stacking ensemble. Saya
Okay.
guna the same dataset tapi saya kasih pecah into several sub dataset.
Oh, that one is bootstrap lah. Bootstrap.
Ya, bootstrap ya.
Yeah. So itu ada efek juga tuh because when you use bootstrap, different model will have different set of data kan. So dia tidak akan melalui jalan yang sama
Hmm,
kan because you giving them different data set mah. Kalau you kasih the same data set, then every ini will have all the opportunity to learn.
oke 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 oke. Paham paham paham.
Tapi, ya, tapi tidak boleh bagi satu set saja, satu dataset saja. At least
Mmm,
tiga lah, at least tiga.
mhm. Oke, Prof. Oke, thank you,
Okay,
Prof.
okay. So, Zul, any question?
Tidak, Prof.
So, so kita punya final exam tuh